In this video, I want to set up the simulation exercise that I'll be coding up in the next video. So here's what we're going to be simulating. Imagine you have 4 kids named, maybe unimaginatively, A, B, C, and D, and they have candy bars. So A has 3 candy bars, B has 1 candy bar, C has no candy bars at all, and D has 1 candy bar. And they're playing this game where at each turn, each kid decides whether to keep all of their candy bars, with, there's some probability that they'll do that, or if they'll pass one of their candy bars to the left, or if they'll pass one of the candy bars to the right. So they can only pass candy bars to their left and right neighbors. So A only has a right neighbor, B, D only has a left neighbor, C, and C has B and D both as neighbors. So let's decide on the probabilities. So maybe it's going to be something like 70% keep and 15% left and 15% right. So at each turn, each kid, so take for example B, thinks what they're going to do. So B is going to decide with 70% probability to just keep their candy bar. With 15% probability, they're going to decide to pass the candy bar to the left. And with 15% probability, they're going to decide to pass the candy bar to the right. Now, A, for example, cannot pass anything to the left because A has no left neighbors. So we'll say that if their decision makes no sense, so for example, if A decides left, then by default, that just means that A keeps their candy bar. So that's how it's going to go. So let's first do the simulation by hand for a couple turns, and then I'll show you how to code that up. So so it's turn number 1. So A has got to decide whether they want this option or this option or this option. So maybe this is the most likely thing, so maybe A decides that they want to keep their candy bar for now. So the way I'm going to describe it here is I'm just going to say 0. Now let's say that B wants to pass their candy bar to the left. So I'm going to do it like that. C, whatever they decide, is going to be invalid, so that's going to be 0. And let's say that D decides to pass their candy bar to the right. So I'm going to draw the arrow like that. So now that they've all made their decisions, we kind of change the arrangement of the candy bars. So A doesn't do anything. B wants to move their candy bar to the left. So let me do this. And let's do it like that. C doesn't want to do anything. D wants to pass this candy bar to the right, but they can't. So this is the situation after the first turn. So now we can do the second turn. So maybe this time A decides to pass the candy bar to the right. And B, it doesn't matter what B decides. Let's say that B says you're passing B's candy bar to the left. C decides to keep their non-existent candy bar, and D wants to pass their candy bar to the left this time. So now here's how we're going to decide to do this. So you might say, like A passes here, B passes here, which means that at the end, things should be the same, but we're going to say no because they all do the passing of the candy bars at the same time. That means that A passes to the left, B doesn't pass anything. This just cancels out because B cannot pass to the right. So the situation is going to be like that. C is not doing anything, and D is passing to the left. So now the situation is going to be like that. So pretty simple. So let's now implement this in the next video.